a linear measuring instrument consisting of a scale rule with a projecting arm at one end, to which is attached a sliding vernier with a projecting arm that forms a jaw with the other projecting arm. The main use of the vernier caliper is to measure the internal and the external diameters of an object. To measure using a vernier scale, the user first reads the finely marked fixed scale. This measure is typically between two of the scale's smallest graduations. The user then reads the finer vernier scale, which measures between the smallest graduations on the fixed scale, providing much greater accuracy.
This is a vernier caliper. There are the outer jaws, here and here. These would go round the outside of an object and measure the diameter. There are the inner jaws here and here. These would sit inside something like a tube, so you could measure the internal diameter of that tube. This here is the main scale. This scale along here has divisions that measure to the nearest millimetre. This here is the vernier scale. This measures to the nearest 0.02 millimetres. It divides 1 millimetre into 50 divisions, each one being 0.02 of a millimetre. Ignore both the main scale here along the top and the vernier scale here along the top. They measure in inches. We use the bottom scale because it measures in millimetres, and we use metres and millimetres as our units of measurement. So as a reminder, the main scale measures to the nearest 1 millimetre, so the precision of the main scale is a millimetre, and the vernier scale measures to the nearest 0.02 millimetres, so that's the precision of the vernier scale. For the sake of simplicity in this example, we'll assume the vernier caliper has a zero error of 0.00 millimetres. We'll now measure the main scale. So if I look along this bottom scale here, I measure 1 centimetre, 2 centimetres, and this zero here on the vernier scale lines up partway between 2.8 and 2.9 centimetres, so 28 and 29 millimetres. I would therefore say the main scale reading on the vernier caliper is 28.00 millimetres. To take the rest of the measurement, you now look at this vernier scale here. If you look really carefully at this point here, you will notice that the vernier scale marking and the main scale marking line up. They line up exactly. That means the vernier scale reading is 0.6, 0.62, 0.64, 0.66 millimetres. The vernier scale reading is 0.66 millimetres. This gives a total uncorrected reading of 28.66 millimetres. As there is no zero error, the corrected reading is also 28.66 millimetres, corrected for zero error. It should be noted it's sometimes a little bit difficult to judge exactly where the vertical line on the vernier scale and the vertical line on the main scale line up exactly. In class, we can lend you a magnifying glass if you wish to look more closely. You should record the reading on the vernier caliper as 28.66 plus or minus 0.02 millimetres, brackets corrected for zero error. The length you're measuring may be an external diameter if you've used the outer jaws around a sample, or it could be the internal diameter if you've used the inner jaws inside a sample. No matter whether you're measuring an internal or an external diameter, the way of reading the vernier caliper is exactly the same. The uncertainty I gave is plus or minus 0.02 millimetres. I gave this uncertainty just because there was one single measurement, and the uncertainty I give if I've taken just one single measurement is the same as the precision of the instrument, i.e. the smallest scale division of the instrument. So in this case, the smallest scale division of the vernier caliper is 0.02 millimetres. My uncertainty might be different if I'd taken more than one reading and done some repeats. Now let's consider zero error on a vernier caliper. What I'm looking to check for is whether this zero here and the vertical line next to it on the vernier scale line up with this zero and the vertical line on the main scale. Both those two lines don't meet up exactly. I would judge that I have a zero error of plus 0.10 millimeters. I have judged that this vertical line here at 0.10 millimeters on the vernier scale lines up perfectly with this line here on the main scale. As I said earlier, it's always a little bit tricky to decide exactly where those two vertical lines on the main scale and the vernier scale line up perfectly, but it is a judgment that you will have to make. So for any reading I was then taking with the vernier calipers, I would have to subtract 0.10 millimeters from the vernier caliper reading of the object to correct for zero error. A similar process would be taken if I had a minus zero error on my vernier caliper, but instead of subtracting that minus zero error, I would add it onto my vernier caliper reading of my object to make sure I was correcting for zero error.
Micrometer screw gauge is a device incorporating a calibrated screw widely used for precise measurement of components in mechanical engineering and machining as well as most mechanical trades, along with other metrological instruments such as dial, vernier, and digital calipers. Number 1. Measure the diameter of a given wire. Number 2. Measure the thickness of a given sheet.
The objects whose dimensions to be measured are shown. Calculate the least count of screw gauge. Select the object you want to measure. Move the screw forward by rotating the ratchet till the object is gently gripped between the screw and the stud. Take the reading on linear scale and circular scale.
A micrometer is capable of measuring a difference as small as 0.01 millimeters in general cases. The vernier caliper only has the ability to measure differences as small as 0.05 in the extreme cases. A single vernier caliper can measure inner lengths, outer lengths, and depths without any change, but a micrometer can only measure one type at a time.